This is the in-class portion of the 1C notes. We're going to start with statements joined by the word and are called a conjunction. That's the set of numbers that are common to both inequalities or the intersection of the two inequalities, what they have in common. Below in example 1, you can see on two number lines that x is less than 3 and x is greater than 0 are graphed on each of the lines. On the third line, we're going to graph those two statements joined by and. When we join them using the word and, we graph their intersection or what they have in common. The two graphs have in common the region between 0 and 3, and it doesn't include either endpoint since neither endpoint is included in each of the sets above. Now, when we write this in simplest form, you're going to write it as a three-part inequality that expresses betweenness. I like to write starting with the number on the left, 0, and then I write my variable x, and then I write the number on the right, 3, and then point the inequalities toward the smaller end. So 0 is less than x, which is less than 3. In B, we have x is greater than or equal to -4, and then the second line we have x is less than or equal to 2, so this time both endpoints are included. If we join those with the word and, we're going to take the region that they have in common and shade that, and then write this in simplest form. -4 is less than or equal to x, which is less than or equal to 2. Again, that expresses betweenness. X is essentially between -4 and 2, including the endpoints this time. In C, we see x is less than 0 on the first line and x is greater than 2 on the second. The region that they have in common is nothing. There are no common regions to both of those graphs, and so in simplest form, this is no solution, and we'll shade nothing on the third number line. In D, you'll notice that these two inequalities are pointing in the same direction. X is less than 4, x is less than or equal to 1. The region they have in common is everything from 1 to the left, including the endpoint. In simplest form, you can just write down what you see on that number line, which is x is less than or equal to 1. Now we're going to move on to the word or. When we use the word or in math, that is called a disjunction. That's a combination of the numbers in the sets, which is known as the union of the two inequalities. So, in example 2, we have x is less than -3 on the first number line, x is greater than 2 on the second. The union is the combination of the two graphs together on one number line. All the numbers that are graphed in the first set or the second set are now shown on the third number line. Now, this is a special situation which we call a disjoint set. That means it's made up of two pieces that are not joined together. And the only way to say this is using the word or. So, when I write down in simplest form, I can simply say x is less than -3 or x is greater than 2. Now, the order of those two statements doesn't really matter. You can write either one first or second. It doesn't really matter. I just always write them down in the order that they are shown on the number line from left to right. In B, x is less than 3 on the first number line, x is greater than 0 on the second. The union of those two, if we join with the word or, is the entire number line. All the numbers that are graphed in either the first one or the second one are all real numbers, And so in simplest form, that is said all real numbers. Or you can use the real numbers symbol there instead. In C, we have a really special one. X is less than 2, X is greater than 2. Joining them with the word or, we're going to join the two sets together, and the only number that really isn't graphed is 2. This is sort of a disjoint set, but there is a really easy way to say it without using the word or, and that is simply by saying what value of x we cannot have, and x is not equal to 2 is the simplest form of that. In D, our inequalities are pointing in the same direction again. X is less than 4 on the first, x is less than 1 on the second. When we join them with the word or, we write their union, which is the two sets joined together. We graph all the points that are graphed in either the first one or the second one. In simplest form, this is x is less than 4. All right, here are ones for you to try on your own. Try number 1 first and pause the video while you do this. Since the two inequalities are joined with the word or, we take their union, and that is all real numbers on the number line. Take a look at number 2 and try this one. Pay careful attention to although we're using the same inequalities, we are now joining them with the word and. So pause the video while you do this. Since these inequalities were joined with the word and, we will find their intersection, which are the numbers between -1 and 2, not inclusive at -1, but inclusive at 2. Now try 3 on your own. Pay attention to the connector, and now pause the video while you do this. The union of these two sets is just a disjoint set, and remember the only way that you can say that is using the word or. So I wrote x is less than -1 or x is greater than 2. That's in the order that I see it on the number line from left to right, but you certainly could just write what you see over here as a final answer, and that would be fine. All right, now try number 4 and pause the video while you do this. When we're joining with the word and, we want the intersection. These two graphs have no common areas or no intersection, so this compound inequality has no solution. Now try number 5, and again pause the video while you do this. Since we are connecting these two inequalities with the word or, we are taking the union of the two sets, and the simplest form of the resulting graph is x is greater than or equal to -2. Last one, try this one, and pause the video while you do this. That's right. Since this is the intersection using the word and, we'll find the area that they have in common, and the simplest form of that is x is greater than 3. Now we're going to move on to and statements, which can be written as three-part inequalities in some cases. But every three-part inequality actually represents an and statement. The statement below in example number 3, now don't copy this down, but can be expressed as -7 is less than or equal to 3x minus 1, and 3x minus 1 is less than 11. Now we can solve each one of those inequalities individually, but the easiest way for us to do this is actually to just leave the inequality intact, and our first step would be in solving either one of these inequalities adding 1. And so we can simply add 1 to all three parts of this inequality. So adding 1 to the left, adding 1 to the middle, and adding 1 to the right side produces -6 is less than or equal to 3x is less than 12. And now dividing all three parts by 3, we get -2 is less than or equal to x is less than 4. And that's our solution We're now going to graph that on the number line, mark off those two boundary values, -2 and 4. This expresses betweenness, that is, that x is between these two values, including -2 but not including 4. All right, let's move on to b. In b, we should be multiplying by the least common denominator. So we'll multiply all three parts, or every single term in this equation, by 12. So 12 over 1 times 5 over 12 is less than 12 over 1 times -1/6 x plus 12 over 1 times 3/4 is less than or equal to 12 over 1 times 11/12. Now I'm going to grab my cancellation pen and cancel common factors. That leaves us with a 1 there, and so that's just 5 on that side. And then canceling common factors, 12 and 6 each have a factor of 2. When we factor of 6, when we cancel that, we're left with a factor of 1. So that leaves us with -2x plus, and 12 and 4 both share a common factor of 4. When we cancel that factor, that leaves us with a factor of 3. So 3 times 3 is 9, is less than or equal to, cancel common factors of 12 on the right side, and that leaves us with 11. Now I can subtract 9, and that'll give us -4 is less than -2x is less than or equal to 2. The next thing we're going to do is we're going to divide by -2, and the inequality changes direction in that case. So dividing by -2, that's +2, is greater than x is greater than or equal to 2 divided by -2, which is -1. Now I'm going to take that inequality and I'm going to rewrite it so that it's exactly as we see on the number line in reverse order. Notice the inequalities are still pointing directly toward that -1, which is the smallest of the three numbers. There's our solution. By the way, the step before is not wrong. It's just not really in a sort of a customary form. So when we graph this on the number line, graph the numbers exactly as you see them in the inequality if it's written from left to right, and then include the number -1, exclude 2, and shade in between. All right, let's check out C. For C, we're going to multiply through by 6, the least common denominator. And so 6 times 5/3, the easy way to do that is just take the 6, divide by the denominator, and then multiply by the numerator. So 6 divided by 3 is 2, times -5 is -10. When we multiply through by 6 in the middle, it undoes the divide by 6, and then 1/3 times 6 is 2. Subtracting 2, and then dividing by 4, we get -3 is less than x is less than or equal to 0. And then we can graph that on the number line. X is between -3 and 0. Not inclusive at -3, inclusive at 0. And one more. -4 is less than or equal to -2x plus 5 divided by 3 is less than or equal to 1. There's only one denominator here, so we just need to multiply all terms by 3. And that means we're multiplying this entire fraction by 3. It will undo the divide by 3. And then we'll multiply the right side by 3 as well. Subtract 5. -17 is less than or equal to -2x is less than or equal to -2. Now the next step in order to isolate x is dividing by -2. That's going to give us a positive because a negative divided by a negative is a positive. It's also going to reverse the direction of the inequality, so that'll be greater than or equal to x, which is greater than or equal to -2 divided by -2 is +1. And since we reverse the direction of the inequality, I'm going to rewrite it so that it looks just like what you'll see on the number line from left to right. And on the number line, our two boundary values here are 1 and 17/2. Now remember, 17/2 is really just 8.5. We don't need to necessarily scale it though. We just need to indicate those two numbers in order to make the graph of this. All right, what you should know is that we are skipping example 4. These problems created more confusion than they were worth last year, and so we will not be covering those this year. And that's it for the lesson.